It's the top of the hour. Let's get started. Hi, welcome everyone to this session of the DETNET working group at IETF 124. The working group is chaired by Lou Berger, who is on site, and myself, János Farkas. Unfortunately, I'm remote this time because the IEEE plenary is in Bangkok next week. And we also have our secretary, Yves Schuler, remote. This is the IETF Note well. I would like to mention that this has been updated a little bit. And I would like to highlight a few things, but I would suggest to check it on your own leisure, and especially the pointers. So by participating in the IETF, you agree to follow the IETF processes and policies. This is just a reminder. And IETF participants are expected to behave in a professional manner and in respect to colleagues. Also, I would like to highlight, be aware of the patent policies and act accordingly. Next slide also reminds about the behavior in a professional manner with respect and courtesy to colleagues. So please follow these guidelines and check the details at your own. On-site, please join the on-site tool to sign in for the blue sheet, and also queue up with the on-site tool at the mic so that we have a single queue we can manage. Please join the note-taking. It is a joint note-taking. We would appreciate if you could contribute and double-check what has been said. And you find the usual placed meeting material. The agenda details you can also find as part of the materials. I think everybody has 10 minutes. And I would like to highlight at this time that we have for the scaling, we have the solution proposal presentations, and we would like to have some poll questions at the end. So please get to your point, leave some time for discussion, and leave some time for the polls as well. Also, a reminder on working group documents, focus on the updates, and also mention the same actually for the scaling and for newer documents, like suggest what would be the next step, what we expect from the working group. The status of our documents. We have 3 documents in the RFC editor's queue, 2 raw documents, the wireless technologies and the architecture. These are done, and also the controller plane framework. Nothing in working group plus call, no recent adoption, and we are discussing the data plane solutions, how to proceed with the adoption at this session as well. We have 2 working group. We have a couple of working group documents that are not on agenda. There is the scaling requirements, which is gated by the solutions work, and there is also the topology Yang work. We have not received any updates recently from the authors. We would appreciate an update on the email list. What's the plans? As discussed at the last session, at the last IETF, we have moved 2 documents to that state because there was no progress. The raw industrial requirements and the raw framework, but they can be revived if contributions happen. We are contribution driven. The milestones. Lou and I have recently updated the milestones according to the progress we had. We recently completed the controller plane and the raw architecture. And we have also updated a few upcoming milestones related to the scaling work. We should progress with adoption and so on. We will be discussing soon. And there are a few items that should be discussed in the working group, we think. We had the ROM framework document and the raw OEM document, which have been not progressed. So not sure if we should remove these milestones or we could expect some progress. Let's discuss on the list, or if anybody has reflections now, please go to the mic. But we are contribution driven, really, so contributions are needed. And an upcoming topic might be multi-domain. There's a contribution and a presentation on that at the end of this session. Liaisons. We received the liaison from ITUT Study Group 13 in April. This was for action. And as I mentioned, we are contribution driven. Nobody has came up with a potential response. Actually, the 802.1 working group received the same liaison, and we were copied in the response, which expressed that they did not have time. And I guess it's good to highlight one aspect, that silence is not consent. This applies to us as well. If anybody has ideas on what to respond, then please make proposals. We have also received liaison with other working group, IETF working groups on IMT 2020, TEAS, CCAMP, and so on. Typically, CCAMP is in the lead in responding. We can contribute on updates. If you have suggestions, please let us know. And the most recent liaison is also from study group 13 on the deterministic networking work. Some work has been consented, and they have started some newer work, other work. And this is for information. We have not sent any liaison. And I would like to mention that we had a very good workshop after the last IETF session on the Saturday. The DETNET working group and the IEEE 2020 sent us group. It was a very good information exchange, standards updates, some experiment, open source stuff. You can check the details. The link is provided. And overall, the agreement was that the collaboration effort is very, very beneficial for both groups. And we would like to thank for all the contributors and everyone who participated. Actually, we ran the discussion an hour longer than the scheduled time, so it was very good. I would like to remind again you about the IPR policies, and on the document status. If there's no update, please update us on the list. Progressing our work, please use the list, and we can also set up meetings, virtual meetings as needed. So if you have, if you would like to do that, please let us know. This is the intro, and I think we can move on to the next presentation.
Actually, Janosch, can you jump back to slide 10, please?
Slide 10, yes.
I'd like to take a moment to see if anyone has any comments on the items to be discussed. We have a minute or two. RAW is an area we definitely have had expressed interest. The issue here is not the interest from the working group, it's the fact that we're not getting updated documents. So, you know, if there's people here that would like to work on that, on these documents, that's great. But we need to see the updated documents. You heard a moment ago about 2 documents going to the dead list because of lack of contribution. We feel that this is in the same category. It's not that there's not interest from the chairs, there's not interest from individuals, but it's not raised to the level of contribution. So with that, are there any comments from the room? Please use the queue so that we can be fair to remote and local participants. So hearing no comments, my inclination is that we oh, sorry, someone on queue?
Oh, no, somebody walked to the mic, but I see just on site too. Sorry.
Yeah, and also just know you're very loud.
Sorry.
So hearing no comments, I think we will send a message to the list saying that we plan to remove these milestones, give the list a moment to respond, and then we'll move forward with removing the milestones. Okay, thank you, Janosch. I think we're ready to go to the next deck. So this is Genu on a working group document.
Hello, everyone. This is Genu from remote. Can you hear me clearly?
Yes, you sound just fine, and you should also have control.
Oh, thank you. So this is the data plane enhancement taxonomy version 4. This is the brief history of this draft. It has started with the chair's request. So far, it has defined 1 performance-related categorization and 6 functional categorizations. And it has specified 2 reference topologies. One is simple, the other is complex. And it has specified 7 suitable categories, also according to the chair's request. One thing I have to mention is that this draft has not been updated since the last meeting. So this is the last version. It has not revisioned yet. So today I'm going to propose the possible revisions to the future draft of 5. The proposal is 2 parts. The first part is what you are seeing here. So as you all know, according to the chair's request, we have to consider for interoperability and compatibility. But this task is not simple. So my and our proposal is to try to cover both interoperability and compatibility of solution with existing legacy networks. For example, we may evaluate performance degradation with mixed domains of the solution and so-called diff-serve, which represented for our legacy network. And also cover interoperability and compatibility among heterogeneous solution domains. For example, we have to evaluate performance degradation with mixed domains of different solutions. By solution, we mean the currently suggested solution being considered in the working group. So in order to do that, I think we have to add a reference topology for evaluations, which is depicted in the next slide.
Before we move on to that slide, do you mind moving back for a moment? Just to be clear, when we brought this up on the list, we were talking only about number 2.
Okay.
And that doesn't change that you're welcome to make this proposal. Just to be, but we think it's worth being clear. We were only considering the case where we're now moving forward to adopt different queuing solutions. It would be good for us to understand how they interoperate with each other, which is, again, item 2, not number 1. Thank you.
Okay. Okay. Anyway, in order to cover the solutions, the intermixed solutions, I think we still have to have a kind of reference topology like this. So this is just an example of what we are thinking about. This is the reference topology of a network of 3 domains, so-called base networks. They are connected like this, cascaded with each other. So if we include such a reference topology in our taxonomy draft, the table of contents would be changed like the one you are seeing on the left side. So reference topology 7.3, this is network for interoperability test. It has to include network topology, flow characteristics, flow path, and utilization level. And the base network can be a domain of either a target solution we are talking about, or strict priority schedulers, which representing the diff-serve network schedulers. And another possible solution. So we are currently having quite a lot of number of solutions. Maybe we have to specify which one we have to talk about and compare with. This is my suggestion. If you have any comments or opinions, please let me know. So this is the brief consideration or rough considerations on interoperability interoperability with other solutions. So basically, we can categorize our solutions into roughly into two parts. One is rate-based solutions, the other is time-bounded solutions. The rate-based solutions can go well with each other because pay-burst only wants property holds over the end-to-end path. The rate-based solutions include C-score, N-score, and even FIFO or strict priority schedulers can be considered as rate-based only if the total service rate is less than the link capacity in every link. So this is one part. And another thing is that this is my rough idea, but the rate-based and time-bounded solutions cannot be very well mixed because the time-bound solution needs to decide the time bounds for packet, the interval. So they require the time slot or interval should be long enough to accommodate the total burst from all the input flows. This I have a reference in the back, so you can take a look. So this slot length determines the end-to-end latency, overall end-to-end latency. However, from the burst accumulation from the rate-based solution domain, it is very hard to calculate the input burst of flow. So one possible solution to that is shaping at the boundary, but it can be complex. Okay, so this is the main consideration. However, from time-bound to rate-based solution can go well because time-bounded solution do not accumulate burst. So this is the basic idea of the interoperability. So this is the second part of the proposal. This is a minor one. I like to put a definition of the terminology of time-bound because I think still there is a confusion what time-bound is. So yeah, this is the proposal to put the terminology time-bound, which is defined as the earliest or latest transmission completion time explicitly specified for a packet. So this is current explanations, not definitions. Rather, they are explanations about the solution and time bounds. So I won't go into the detail, but you can take a look. They are kind of already well explained. Okay. And this is the recapture of the 7 suitable categories. They are numbered with the section number, which appeared in the table of contents. So from 6.1 to 6.7, there are 7 suitable categories. Okay, this is the future plan. Thank you.
Okay, you've proposed some changes in the document. I think it would be good to get those changes out. And you, as editor, you have a choice of publishing the changes or reviewing the changes on the list first. I think it's a little, I personally find it hard to agree or disagree with a set of changes without seeing the actual text. So I think it would be really helpful to get that new version so we can take a look at it.
Okay, if there is no clear objection, I will update the revision and distribute to the working party as soon as possible.
Okay, yeah, I think you as editor have the discretion on that of how you gauge working group consensus.
Okay.
So thank you. I see that Xiaofu is in the queue.
Hello, can you hear me?
Yes.
Okay. Jinu, thank you for presentation. I have a question on page 5. You say that from rate-based to time-bounded is tricky. I don't think it necessarily means that it will use a long time slot length, but actually it means that the offset between the incoming time slot and the outgoing time slot is longer, but it's not the length of time slot itself is longer. Thank you.
Xiaofu, if I understand you correctly, you are saying that the time bound, the value of the time bound or the length of the time bound is variable. So that the
Yes, the time slot length may be fixed.
Mm-hmm. Yeah, it is fixed. What was your question? Sorry. Okay. Maybe we can discuss offline. Sorry about that, Xiaofu. Okay, so this is my second slide.
Yeah, before you get started, first of all, Shafu, thank you for the comment. I think taking it to the list would be helpful, just to repeat the comment. This is the first of a number of solution documents. For each solution document, we intend to poll the working group. So please do join either online or on your on the mobile tool. We expect to ask two questions. The first is, have you read the document? The second one is, should we be working on this as part of the working group activity in this area? So with that, please begin. Thank you.
Thank you, Chair. So this is the latency guarantee of stateless fair queuing, so-called syscore. This is the brief history of syscore draft. It was included in another draft, so-called asynchronous deterministic networking framework, which started in June 2022. However, from the working group's request, it has separated into an independent draft on June 2023, 2 years ago. And currently it is in a fifth version. As you all remember, it has been through intensive debates, discussions, and revisions from many participants, and discussed in the enhancement data plane enhancement solution in interim meetings, which held like 3 times a year with the Mr. David Black. So yeah, we've been through hard debates and discussions, and this score is a part of one suitable category, that is 6.6 flow level rate-based unbounded solution. So syscore is the only solution currently being suggested in this suitable category. It has not been revised since the last meeting as well, because there was nothing to revise, I think. However, according to the chair's request, we have conducted the simulation study for interoperability test. So here, this is what you are seeing is the simple network, which appeared in topology draft. I mean, sorry, this is not the topology draft. It is taxonomy draft. Appeared in the taxonomy draft as the reference topology one. So this is the reference topology one. It only has 9 nodes, but the flow paths are complex. And the simulation network for the interoperability includes 3 such a network, which are called base network here. They are cascaded from domain 1 to domain 3. So there are flows from coming from domain 1 and to domain 3. Okay. These are the flow types we have been used. There are 3 flow types, A, B, C, as a high priority, and best effort flows. Their service rates, maximum burst size, and packet length, which are variable, is described in this table. Actually, A stands for audio, B stands for video. It doesn't stand for, but yeah, B is video traffic, and C is the command and control traffic. This is the simulation environment. We have used OMNet++, which is very well known simulation platform. All the links are 1 gigabps capacity. I understand the currently used links are much higher bandwidth, much larger bandwidth, but this is for just simulation speed. And each source generates flows for different destinations, and flows travel at most 21 hops. So I would say this is very long trip. And for the uh, for the strict priority scheduler, flows A, B, C are scheduled as high priority traffic, best effort as low priority traffic. The maximum utilization without best effort traffic is about 63, and with best effort traffic, it is about 85. So this is highly utilized network. I personally think when we conduct simulation, we always have high utilization. Otherwise, the pro and cons of the schedulers cannot be revealed. Okay, so this is the result. You are looking at the box plots of C-score, CSPC. SP stands for strict priority scheduler. So basically, it is the interoperability with the legacy DiffServ networks. So simulations are repeated 100 times. And in a simulation, there are a total of 1,000 packets are generated per flow. And this 1,000 packet generation is according to the stochastic Markov on-off model. So when on, it generates packet as much as possible. So it makes the burst. In off state, it doesn't generate packet. So it is naturally very highly bursty environment. Okay, so as you can see, the Cisco only network has the smallest end-to-end latency bounds, and it also has very little jitter. And mixed networks show the performances in between the Cisco only and strict priority only networks. Okay, so Cisco works with SP networks, legacy networks seamlessly without any additional configuration for the interaction. So it's a plug and play. Only thing necessary before flow admission is the resource reservation and admission control throughout the end-to-end path. But it is already a well-established function. And syscore and time-bounded solution can also coexist if the time-bounded solutions are applied at the small edge size, such as LAN. And if there are flow shaping functions between edge and core nodes, we understand that flow shaping function can be complex because it has to be executed per flow basis. But the small edge side, LAN, is small, and the number of flows generated and or destined to that LAN are not that many, then per flow shaping is possible. And if that is the case, these two solutions can also coexist. Thank you.
Great, thank you. While we take questions, I'm going to start the poll. The first question is, have you read this draft? So Shafu, please go ahead while we're doing the poll. And I'm going to run the poll for about 30 seconds and then move to the next poll.
Thank you, Jinu. I have a minor comment. Yes, I have already studied your document and thank you for the sharing. My minor comment is that can you add some more description about the evaluation and the reference topology in the document? I think that is lack.
Oh, yeah. I definitely will add the reference topology tree in the taxonomy draft. But including the simulation result in the C-score draft, I
Yes,
think
I think so.
that's not very appropriate because we have been through the simulations of the reference topology 1, reference topology 2, and then reference topology 3 now. I don't think that's valuable enough to put in the Cisco draft itself. But I'm open to other suggestions. If you really want to put those things in the draft, Cisco draft, then I will consider putting in that as some kind of appendix, informative material. Thank you.
Okay, thank you. I think it is necessary. Thank you.
And the second question is up. If anyone else would like to join the queue and make a comment, please do so. We have about half a minute left, maybe a little less. So on the first of who's read, it was split, and I would say not heavy participation. And the interesting thing here is we're seeing more people support working on this than have claimed to read the draft, which I think is entertaining and maybe a positive positive thing. And we will take it under advisement as we move to the next presenter because we want to be fair to everyone. Xiaofu, are you presenting?
Yes, I will present the it. Thank you.
Okay, great. I'm taking, you will have control in just a moment. Someone has a cat. That's a new participant.
Okay, I
Xiaofu.
see the button. Okay. So there were minor updates from version 7 to 18. It clarified the one flow with a small SBI apply large delay level. It will not cause fast accumulation over time. And second, it clarified the interoperability solution between EDF and the strict priority is to treat the SP domain as a single hop between EDF nodes. And the SP domain with limited hops, so to provide the low jitter transmission. Okay, a concern raised by Yanis in the last IETF 123 meeting about the category conflict between EDF and Cisco, and a corresponding clarification has been sent in the mail list. EDF applied the category list defined in the document, in the taxonomy document, while Cisco applied another list that better reflects the derivation positive but differs from the ordinary or from the order of the list in the taxonomy document. So we suggest that all solutions apply the same category list defined in the document later. And according to chair's instructions, we checked the category and sent the implementation status to the mail list. EDF in time mode falls within right-bounded category, and EDF on time mode falls within class level non-periodic bounded category. EDF has been implemented in ZTS root, and with developed ASC model. We have taken interoperability test between EDF and SP in the laboratory. SP domain has limited hops to provide low jitter transmission, and EDF only enabled an ingress node, aggregation nodes, and egress node. The end-to-end latency is met, and the jitter is with approximately 30 microseconds. So for your information, this is again the overview of EDF solution. It basically contains 4 functions: determine the deadline of each packet, and the second, insert the packet to the queue based on the deadline, and the third, admission control based on the schedulability conditions, and take reshaping or latency compensation of ineligible arrivals. So this page is the evaluation on grid reference topology. We take 3 delay levels, 200 microseconds, 700 microseconds, and 1100 microseconds for the command and control flow, audio flow, and video flow respectively. The end-to-end bound delay equals to the bound latency per hop, multiple hop count. For example, for video flow with 7 hops, it is 7,700 microseconds. The end-to-end bounded jitter is 0 with the help of latency deviation and anthem mode. Okay, this page is the evaluation on run mesh reference topology. In the run network, a single delay level, 225 microseconds is selected for all flows, while in the core networks, 2 delay levels are selected, 400 microseconds for CC and audio, 700 microseconds for video. The end-to-end bounded delay for CC and audio is about 4.75 milliseconds. For video flow, it is 5.95 milliseconds. The end-to-end bounded delay, bounded jitter is 0 with the help of latency deviation and anthem mode. So, according to the definition of functional characteristics in the taxonomy document, EDF is non-periodic, class level, time right bounded for in-time mode, and time bounded for on-time mode. So this is the history of commands and the related response. The authors believe all of them has been carefully addressed. I will not go detail in each item. Next, we will follow the adoption process of working group, and we welcome any questions and comments. Thank you.
Great, thank you. As before, if you would like to enter the queue, please do so. We're going to start the same 2 questions, this time for slot number 4, what was just presented. Okay, going to move on to the next one. The interesting thing is on that previous one, also an equal split, also approximately the same number who read the previous draft. So again, not overwhelming readership on either. Also not overwhelming participation in the poll. So this is the question of, do you think we should be working on this draft? Here too, we have more participants saying yes than who said that they read the draft. I think that's also a good sign. I think these are pretty similar results to the previous one. Although the participation is a little higher. Thank you all. We're going to move on to the next speaker, which is also Xiaofu. Okay, you should have control.
Okay, I see the button. Thank you. Sorry, I see the slides, the previous one. It is the EDF, not the TCurve.
Interesting. It may be that the same slides got uploaded twice. I'll try again. Also possible I selected the wrong ones. I think this is the right package, right?
Sorry, no, it is still the deadline-based forwarding.
Yeah, I see. My mistake. Completely my error.
Okay, this is, thank you.
Yeah. My apologies.
So the main updates, there is no significant updates from version 12 to 13, but we invite a new course who are interested in this document, and we have some editorial modifications to make the text clear. A comment raised by Following at the last IETF 123 meeting about the number of queues in TAS and TQF. We have taken further discussions in the mail list with the following clarifications. All 8 traffic classes queues in TAS can certainly be controlled by GCL. However, only one of them is dedicated for higher priority scheduled traffic. The allocated slots for non-ST queues in GCL are not really allocated to them, and we lose slots once new ST flows need to be set up. And during non-ST queues open state, other mechanisms such as CBS or ATS further decides which non-ST queue can actually send the packets. And all M queues in TGF are dedicated for high priority DETNET flows. So the summary of improvements of TGF is that we support multiple orchestration period instances, and the scheduling period is decoupled with and mapped by orchestration period. The slot-based queue can be instantiated as round robin or FIFO, and queuing delay can be controlled by time slot offset is not only by the length of time slot. And the last one is we need to know the time synchronous. So according to the chair's instructions, we also checked the category and send the implementation status to the mail list. TGF falls with flow level periodic bounded category, and TGF has been implemented in ZTE route with the developed ask model. We also have taken the interoperability test between TGF and the SP domain and CINI system. TGF system, TGF time slot resource is arranged based on the worst case latency of SP domain to absorb the jitter of the SP domain and the border node. So the target jitter is within 20 microseconds. That is 2 time slot. So this slide again shows the overview of TGF mechanism. Basically, there are 3 functions of TGF. The first is to set up BTM between the agents and nodes. And the second, set up FTM for each flow and insert packets to the queue based on the outgoing time slot. There are also some comparison between TGF and TS and CQF. I will not go to each item for the comparison. So this page is the evaluation example and grid reference topology. A trajectory period length 5 milliseconds and time slot length 100 microseconds are selected. The principle of time slot allocation is to ensure that the offset between the incoming time slot and the reserved outgoing time slot is less than the probable latency bound of each type of flow. So the end-to-end bounded latency equals to the sum of bounded latency per hop. For example, for the video flow of a path flow, source 2 to the transit node 236587, and finally to the destination 3, it is 7 milliseconds. And the end-to-end bounded jitter is 2 times root length, that is 200 microseconds. We can get the 0 jitter with the help of time deviation. Okay, this page is the evaluation example and mesh reference topology. Also, we use ultrafiltration period length 5 milliseconds and time slot length 100 microseconds, both for rain and core networks. The end-to-end bounded delay for CC flow is 3.8 milliseconds. For audio flow is 5 milliseconds, and for video flow is 8.8 milliseconds. The end-to-end bounded jitter is also 200 microseconds, that is 2 time slot lengths, all 0 with the help of time deviation. So according to the definition of functional characteristics in the taxonomy document, TGF is periodic, flow level, and time bounded. Yeah, so again, this is the history of comments and the related response. We also think that all of them are carefully being addressed. So we will still follow the adoption process of a working group. Questions or comments? Thank you.
Any questions? Same pattern of questions, polls, excuse me. We'll give it a minute. We seem to be getting responses in spurts. I guess we have bursty queuing going on. All right, well, we started slow on that. We've actually had the most participation on that poll, and with a little more have read. Do you think you should be working on this solution in the working group? Okay, in this case, we've had fewer people saying yes than have read the document, but not far off from that. You know, I view these polls so far as not showing anything materially different between each of the polls. Although, again, this one I think has had the highest number of respondents. Xiaofu, thank you so much. And with that, we're going to move on. So, Torlis, I believe you're next. Just give me a minute.
So one remark up front and request. I was actually requesting one slot for 2 solutions. So if you do, when you do the adoption, the questions, please consider the 2 solutions separate.
Okay, we'll do
TCQF and GLBF.
We'll call you A and B. How's that? And you have your own clicker.
Okay, thank you. Right, so this is looking at the update to the TCQF and the GLBF draft, and flow interleaving being an optional component of both of them. So this is trying to answer to the chair's question. Right, so added the text to that. Yeah, as I mentioned, these are 2 separate solutions, TCQF and GLBF, and we'll get to their differences. TCQF, solution scope. So I put that into section 6.1. And the taxonomy is what I presented already at 123. So it is a latency-bound category 3, sum of max burst size capacity, periodic solution, yes, Teffrick granularity class-based, left and right bounded, service order arrival, suitable for category 6.3, class level periodic bounded DETNET solution. The status, or no, wait a second, I'm first going to GLBF. GLBF is this solution which is more far out looking. It basically eliminates the cycle. It uses the damper approach. And it specifically is a subset of the damper solution that by using the IEEE TSN ATS calculus can be implemented in FIFO instead of just general purpose FIFO. So the dominant factor for latency is category 3, so that's exactly the same as for TCQF. It does not need to be the same on every hop like the cycles, so it's more flexible. It is not a periodic solution, so that's also a difference over TCQF. It makes the configuration in the network of different links a lot more easy. Class-based, tight per hop, left and right bounded, priority order of arrival, and this is DETNET categorization 6.5, class, interrupted by clock, non-periodic bounded. So can't see that here on the slide. So, but it's non-periodic. So then the status. So for TCQF, that's really an available solution. So there's a high-speed proof of concept router ASIC implementation, 100 gigabit Ethernet ports for many years, which was tested in academic network on a 2,000 kilometer network. The document, the draft contains a reference to the English translation, and there is a research paper with a simulation-based validation in all type of different topologies. The GLBF is more on the academic side, so I don't think high-speed ASIC has been built for that. So there is a research conference paper, an open reference simulation implementation, also a journal paper going to more details, and I think there are also other academic follow-ups on that. And so that solution, I think, is well known for decades, but the high-speed implementation, I think, is just becoming now available. So yeah, so and also just wanted to, I think that wasn't good on the slides. The flow interleaving is a feature that doesn't happen hop by hop, but one of the important part is to look at the possible utilization of, let's say, for example, millions of small IoT flows in the network, and that requires flow interleaving, and that's a specific form of timed aggregation on the ingress, which can be combined. And in 123, we had the question on how we deal with that. So as the process stands right now, we're simply declaring the flow interleaving to be a part of each of the solution in a separate document, and each of the two documents refers to that.
Okay, you have a couple of questions. We're going to start with Janu, but we're also going to run the polls, particularly because we have 4 questions. So this
Hello,
is,
Torles.
Yep.
one moment. This is, have you read TCQF? And then we're going to do the second poll for TCQF, and then we'll move on to the other documents. And we're going to interleave with the questions. So Janu, over to you, please. So Janu?
Oh yeah. Hello, Torles. So your solution belongs to the category 6.5.
Okay. The second one, right? GLBF is non-cyclic.
So 6.5, category 6.5.
Yes. I thought 6.5 was non-periodic and 6.3 was periodic. Otherwise, there is a bug in the text.
Yeah. So is this the only solution in category 6.5?
No, this one is in 6.3. TCQF is the 6.3 solution, the periodic one, because it's cycle-based.
Could you go back to the slides? Maybe I'm not so sure about the page number, but there is an indication that this solution belongs to 6.5.
No, that should have only been the GLBF one, and the TCQF slide should have said 6.3.
You can go backwards.
Oh,
And we're going to move on.
6.3. Yep. TCQF 6.3.
GLBF. What about the GLBF?
TCQF is cycle-based. It's 6.3.
Yeah. What about the other one?
6.5, not cycle-based. GLBF.
Yeah, that's what I'm talking about. So 6.5 has two different solutions currently, right?
Yes, those are two different solutions, which were also why we're polling 2 times. TCQF
Yeah, I mean,
is the hardware-proven deployable solution for which all the simulation, all the implementations, everything is possible, has been proven. And GLBF is the academic solution based on the dampers, which removes a lot of the constraints, but keeps all the benefits of these cycle-based solutions. So
yeah, I understand. But what I'm saying is that the suitable category 6.5 now has two different solutions, yours and Xiaofu's.
Oh, okay.
That's what
So
I'm saying.
then let's take that to the list so that we can compare that best. Yeah.
Okay, thank you.
Okay, so on the first poll, you had similar number of readers as everyone else. This time, I would say that there are fewer numbers saying yes, but I don't think it's a huge difference because of the small participation.
There is one guy who couldn't vote.
I added that in mentally. Remember, these aren't votes, these are impressions. And, so now we'll move on to reading the documents. This is instead of our hums because it's tough to hum across the mics. So have you read the second document, GLBF?
So in the meantime, Shafu is in the queue with a question.
I'm so sorry, Shafu. Yeah.
Go ahead, Shafu, and tell us if you could walk back to the mic to answer.
Thank you. Actually, I have the same question with Jinu about the 6.5. We have currently two solutions. I have already sent the my consideration to the mail list. Thomas, if you have time, can you respond that we can discuss further in the mail list? Thank you.
Sorry, can somebody? I didn't.
I believe he said that he sent some concerns to the list.
Okay.
And are you able to respond to them?
On
Did I get that right?
on GLBF on the list? Sure. Yeah, I'll find them.
Okay. And I guess the other point he made was the same as Gino, that 6.5 now has two solutions. But as Manny said, let's continue the discussion on the list on this aspect.
Okay, so the last question about readership was, I put this in the notes, was notably fewer have read that one, perhaps because it wasn't on the agenda, but because it didn't show up as two agenda requests.
Yeah.
So only as one. And likewise, we're getting smaller participation on responding if we should work on this. It's split, but it's really small numbers of participants. So. Okay, thank you for the polls. We're going to, I think, move on site. Mitchell. One second.
Hello, everyone. My name is Yunchul Liu from E3. I will present the update of the on-time forwarding with the Pi4Q solution. In this version, main update is Chapter 7. Previous Chapter 7 is only refer the scaling requirement draft, but it has been divided into two subsections. Chapter 7.1 is refer the scaling requirement draft, and other 7.2 is refer the taxonomy draft. Chapter 7.1 has been updated to reflect the updated scaling requirement draft. Especially it added support multiple mechanism in single and multi-domain parts. As shown this, when both in-time and on-time service arrive, on-time traffic, which is the which is the more sensitive to jitter, according to the SLA, is mapping to the PIFOQ. And while the in-time service traffic, which is not required the jitter requirement, is mapped to the FIFOQ. And when there are eligible packet in the higher priority PIFOQ, the packet are transmitted first from the PIFOQ, and otherwise the packet from the FIFOQ are forwarded. In this way, the on-time forwarding solution can support the multiple mechanism solution. Chapter 7.2 newly added the include functional characteristic and suitable category part from the taxonomy draft. Chapter 7.2 describe the on-time solution fit into the fourth suitable category, which is the flow level and non-periodic bounded type. Currently, it is only one solution in fourth suitable category. This is implementation state of on-time forwarding solution. On-time forwarding solution is implemented by FPGA, and it's implemented to the transmit metadata such as remaining upper and lower bound to the next node based on the post-stack and Paris network action, and plan to implement the in-stack method as soon. And solution is currently being tested on the actual Korean network with 4 different sections. One is 4 node over the 500 kilometer section, and second is 8 nodes over the 1,000 kilometer section. 3 is 4 nodes over the 90 kilometer section with the OTN sub-layer. Final section is 7 nodes over 1,119 kilometer section. We conduct the test target latency requirement of the 6.5 millisecond across the multiple paths and distance. The goal of this test is verify that even under congestion condition, packet traveling the multiple paths between the Seoul, Daejeon, and Busan could still meet the latency requirement. This is the testing result. You can see the this fourth on-time service flows successfully satisfy the 6.5 millisecond latency requirement. And meanwhile, the in-time service transmit together, showing the different latency range to the 2.4 to the 6.1 millisecond. This demonstrated that on-time forwarding method effectively guarantee the deterministic latency, even when the multiple service case. Thank you. Any question?
Shafu?
Thank you for the presentation. I I have the same questions as I think I have already raised in the last meetings. That I think this solution seems that lack the mathematical formula. So that I'm not very clear that how to guarantee that if you want to transmit the observed packet, how to guarantee that any preceding packets of all other flows will not the transmission time will not be larger than the time required for the observed packet.
We are doing the first poll now, so if you haven't seen that. We're also trying to look at the, it didn't come through completely clear at the end, and we're trying to look to see what the transcript is capturing, whether that's helpful. I think it is a little helpful, no? Okay, so he first started out talking about that he had already asked the questions at the last, I think it was at the last meeting or on the list, I forget which. And,
I just didn't remember this.
okay, so Shafu, I don't know if you want to say that. He didn't remember the questions and is asking to move to the list. Sorry about that.
Okay, I will send the list again.
Okay,
Thank you. So even fewer have read this draft. Yeah, I would say this is the, I'm sorry, the smallest number of people who have read the draft, but I'll still do the same polls. So we're on to the second poll of following this, working on this technology in the working group. Well, about the same number that have read are saying, yes, we should work on it. So that's something, but clearly not enough participants, enough readers to make any decision on this. Thank you. I believe you also have the next slot.
Yes. I will present the update of the N score. This work is collaboration between the ETRI and Sangmyeong University. This version main update is also chapter 7, divided into the two subsections. One is refer to the scaling requirement draft, and other one is taxonomy draft. Chapter 7 has added the refer to the scaling requirement draft. As shown in the figure, N-score core node uses the eligible time and finish time calculated by the previous node along with the time difference. So N-score does not require the time synchronization and can offer the stateless. So which is does not matter to the large number of flow. And link delay is a additive part of the end-to-end delay. So large propagation delay also does not problem with the N-score solution. And since the admission control only use the service rate, so when a link flow add and leave link flow fluctuation does not flow or fluctuation can be easily addressed by N-score automation control. And N-score also uses the dedicated piper queue, so which can support high-speed operation and can support the multiple mechanism by appropriately mapping the each flow to the PIFOQ or FIFOQ based on SLA. Chapter 7 has been updated. Chapter 7 describes the N-score suite belongs into the suitable category number 2, which is flow level rate-based left-bound solution. This is implemented state of the N-score. N-score has been mathematically proven and had conducted a software-based solution based on the reference topology 1 of the taxonomy draft. And we performed the 3 types of the flow, audio and video and control flow. I'm preparing the to submit paper to with the test result and proof. And we also plan to the implementation N-score and C-score each other using the FPGA based. And FPGA currently FPGA we designing the FPGA module function for the implementation, and it's being designed to the transmit metadata to the next node. Is based on in-stack MPLS network action based. It's been, do you have any question?
Xiaofu is in queue.
Thank you. I have the same question for the Cisco. I think it is better to add some more description for the evaluation and the reference topology in the document. That way, let people to better understand how the solution work. Thank you.
I'd like to see a description of the topology in order to understand how the solution works.
This solution is
in the simulation, used in the simulation.
Simulation topology is using the taxonomy draft reference topology.
Yes, but the taxonomy document just provide the common reference topology. However, the evaluation result of each solution, I think it is better to add some description in the solution document.
You'd like some description of the emulation in the document. That's what he's asking for.
Okay.
Thank you.
Okay, thank you.
Okay. Again, small number of readership. I'm going to do the same poll on working on the technology. Okay, so pretty much the same results, around the same number that I've read, think it's worth working on the technology. Overall, I would say that all these polls, it's really hard to see what real information we got from it. There's small numbers of readers, similar numbers as readers saying, yes, this is technology we should work on. That's, do we take away from it that the people contributing want to see it move forward, or do we take it something else? So I think Janos and I have some consideration and some discussions after the meeting. For the working group, I think overall, the ask is to go read all the documents, not just the ones you're interested in, so you can have an informed opinion. Then as a group, we're going to have to decide how many of these we adopt, and then whether we adopt multiple in the same categories. For me personally, this is a personal statement, I don't understand enough of how each of these solutions work with competing traffic flows and different traffic types. To me, that means I should go make comments on that sort of reference topology and maybe improve that so I get more information out of the documents. So I'll take that as an action for myself, but it's an example of what each of us should be doing is reading the documents, seeing where there might be gaps in information that we want, and then trying to help the group get there. Janos, anything you want to add?
Nothing special. I agreed on what you said. Even though we should think about the reference topology, and I would really encourage seconding what Lou said. Everyone reading all the proposals on the table to be able to make a solid decision which one to adopt. Thank you.
Okay, with that, we're leaving queuing. Still related topic, but on to flow aggregation. Tianji?
Change the topic completely.
It's not complete change.
Oh wait, no, I lost the order of the track. So, yeah. Okay, certainly. Okay, now it's good afternoon, everyone. This is the draft and co-authored with my partners. Here, this is a flow aggregation for enhanced DETNET. This is a third revision. And then, okay.
My mistake. I didn't give you the clicker control. Wait, just one moment. The number of buttons you have to click between presentations.
Okay, sure. By the way, I'm Tianji on behalf of co-authors. Okay. Since this is the third revision here, I just try to give some updates from not just the last version, but from other versions before. Because from the past presentations, we have got quite a few comments. And also from the alias part, thank you, Torres. Thank you, chairs, about the recommendations and the comments or some feedback on how to improve it. So basically, the first one is just like from the chair suggestion is to make it informational. And one thing we have gotten from the meetings and from alias is to try to streamline what we want to achieve. So basically, like to say, okay, what is the motivation for this draft? And revolving around this motivation, and then what is some new requirements that are going to step from, and based on that, what is some enhancement that can be proposed for flow and aggregation. So that is the second bullet here, is the most important change we have put into the revision number 3. And then also for the realization, because people have comments regarding the 5GS part. For that things, actually, we used to demonstrate the exemplary consideration of applying the proposed enhancement on the 5GS case. So it's like an exemplary consideration or demonstration about our proposed enhancement. So that is the third item there. And also some reference, this is the logistic part and editorial. So these are 5 major items talking about the changes in the new revision. Okay, here is the first one. It's the motivation things. Okay, try to streamline here. So what is the motivation? Okay, what have motivated us to go for the flow aggregation? There are 2 things, one from the data plane, one from the control plane. For the scaling requirement for that document, it proposed for the DP, the data plane requirements, and it should support the explicit aggregated flow identification, that is one thing, and also to provide aggregated flow over multi-domains with a different level of SLAs. So this is from the DP. There another document is regarding by colors and some other co-authors on the DETNET multi-domain part. This is on the CP. That one discussed the consideration to achieve the end-to-end QoS guarantee for aggregated flows that span across multiple domains. So here, this 2 are the major motivations, that have been motivated us to go for the flow aggregation. So here is the document, our document, try to specify, okay, I'll describe the specific requirements and the enhancement for flow aggregation in DP and the CP in scaling networks that span across multiple domains . So basically scaling networks and across multiple domains. The gap here, we did some investigation and from existing work, just address either this or not, or that one. So this is the gap. So here is the motivation and what we want to do in the draft. Okay, revolving around the motivation, and we summarize some requirements for flow aggregation in scaling networks and across domains. So this is the things. There are 3 of them. The first one, of course, to aggregating the data flows across domain with some target to achieve end-to-end QoS guarantee for aggregated flow across multiple domains. And also the flow aggregate should be identified, and also the related information should be exchanged and coordinated among different network domains. That's the first requirement. For the second one, it aggregated with fine-grained the QoS provisioning. So this one is specified for a scalable number of flows that have coexisted. And for the applications requiring different level of SLAs. And also for DETNET flow with same level of service requirements, they should be aggregated to receive collective treatments and forwarding behaviors based on some number of predefined classes. So that's the second requirement. And the last one is the aggregated flow with the burst flow across multiple hubs. So that one, actually, we got a comment from Torres, thank you. It's for this one, because there's some red font here showing the flow frequently joining and leaving, and that may potentially lead to accumulative bursts of flow across multiple hubs. So, and then based on that, we say, okay, well, they should have some for flow aggregate. They should have do some coordinating processing of the packet within the aggregated flows. So this is the requirement. Remember the motivation revolving around that. We summarize the requirements in scaling networks and also across multiple domains. With this one, and then we propose some enhancement in these scenarios. The first one is the flow classification. This is to address the requirement number 2. Here is the scaling number of flows, and also to provide some collective treatments and forwarding behaviors based on some predefined classes. So this is the flow classification for requirement number 2. And for flow identification is to address requirement number 1 here. It's a end-to-end QoS guarantee for aggregated flows span multiple domains, and also the identification, flow identification while related information should be exchanged and coordinated across domains. And the last one is the flow coordination, and then to address both the number 1 flow the flow classification, and also the flow coordinate. This one, here about the flow aggregate flow across the hubs there. So this is the enhancement part. Okay, so motivation, summarize requirements, and the proposed enhancement. For this one, here, no, I'm not going to delve into the details here, but as I have stated at the beginning, we use the 5GS case, okay, as an exemplary consideration of the flow aggregation, okay, when applying the enhanced. The proposed enhancement for these things. Okay, so this is just like exemplary demonstration here. Okay, so that is all motivation, requirement, summary, and proposed enhancement for flow aggregation in scaling networks and across multiple domains. So this is the thing we try to streamline what we want to achieve and the objective. Thank you.
Great, thank you. Questions? We're going to pull this. Similar questions, although we're going to ask about interest in the topic, not the particular document. Just give this a moment more. Okay, so we have about a little less than a third of the room has read the document. Let's see interest in the topic, and this can be based on reading or listening to the presentation. So we're looking for interest in bringing this topic into the working group as a working group document. So right now I'm seeing no objections, but again, a smaller number of participants, still less than a third of the room participating, but no objections. That's interesting information. Okay. So thank you very much.
Sure, thank you.
And with that, we're going to move on to Jinji. No.
Hello.
Okay. Yes, I'm bringing up your slides. Just give me one moment, please.
Okay, thank you.
Unless someone else just shared. Did someone share slides? I don't know who just did that. Looks right. So we'll go forward. Assume one of my co-chairs or secretary did that.
Okay, thank you. And hi everybody, thank you for the opportunity to present our work on anomalous package handling for DETNET. This is a joint work by China Unicom and ZTE, and I'm Jinjie Yan, behalf of the co-authors. This is our first presentation to the DETNET working group, and we look forward to your feedback. Next slide, please.
You should be able to control it.
Okay, thank you. First, DETNET provides deterministic guarantees through resource allocation at the control plane, bounded latency, low jitter, and low packet loss. However, aggregation nodes face challenges when multiple flows converge and share reserved resources. Anomalous forwarding behavior can occur in the data plane due to various factors. Enhanced handling mechanisms are needed to preserve deterministic guarantees under these conditions. Let me explain the 4 root causes of anomalies. First, diversity of flows. Deterministic flows exhibit microburst and packet size fluctuation that divide from control plane assumptions. Second, soft-wire and hardwire limitations. Algorithmic flaws in scheduling and hardwire constraints may lead to imperfect resource allocation. Third, high-priority protocol messages. For example, the ARP packets and other protocol messages can preempt service packets and disrupt scheduling. Fourth, resource conflicts at aggregation node. When multiple flows converge, allocated resources can be exceeded despite control plane planning. This is a most critical issue. The result is anomalous packets are detected when the queue depth exceeds allocated capacity for the current scheduling cycle. And why do we need especially handling mechanisms? Let's examine the current approaches. First, the direct discard, which may causes data loss and wireless deterministic guarantees. Buffer and wait may lead to unbounded delays and potential queue overflow. Best effort treatment may lose deterministic scheduling and priority. And PREOF at the control plane requires excessive resources reservation, may lead to poor utilization. Here's the core issue. All these approaches result in queues degradations may be worse than the traditional queues. If DETNET performs worse than traditional queues when anomalies occur, what is the value of deploying DETNET? So we need a plan, or we need a data plan mechanism that preserves deterministic guaranteeing for traffic within the allocated capacity while handling anomalous packet appropriately. We propose a policy-based framework with 2 complementary policies. First is the squeezing policy, provides temporary deferral to the next time slot while preserving original scheduling information. This maintains deterministic characteristics. The second is degrading policy, redirects the packets to lower priority queue when anomaly accumulation exceeds the threshold. This is for severe or persistent anomalies. Key characteristics. First is configurable by control plane and flexible deployment, can be deployed individually or combined. Compatible with various queuing mechanisms and includes safeguard mechanisms to prevent the unbounded delays. The squeezing policy uses a threshold-based activation. When anomalous packets are detected, they are in-queued and squeezed into the next time slot. But critically, the original scheduling information is retained for downstream processing. Let's look at this example. Packets 1 and 2 are normally in-queued into Q1 for time slot 1. When packet 3 and 4 arrive and exceed the threshold, so they are squeezed into Q2 for time slot 2, but they still retain their original scheduling information, for example, the time slot 1 label. This allows downstream nodes to recognize the original scheduling intent. The benefit is temporary capacity expansion to avoid data loss during the transient anomalies. And the degrading policy is triggered when anomalous packet accumulation exceeds threshold or when squeezing safeguard limits are reached. There are two deployment moves. First is combines with the squeezing policy. Processes traffic exceeding the squeezing threshold. And mode 2 is operates independently, which can be applied directly to anomalous packets exceeding the buffer capacity. The implementation may vary. For time-bound queuing mechanisms may adjust target sending times with flexible delay configuration, and for those periodicity queuing mechanisms may redirect to lower priority queue and to maintain the stability. We propose reporting to the controller for reorchestration and resource expansion decisions, and to downstream nodes to adjust forwarding behavior. Reported information includes nodes and port IDs, flow IDs, and policy details like squeezed bees and priority changes. This provides visibility and enables proactive network-wide anomaly management. Thank you. And this is the first time of our jobs presentation, and so we are very interested in your feedback and comments. Any questions?
Yes, yeah, speaking as an individual, private opinion as an engineer, like I think there are most of the aspects you brought up are not really anomalies, but things just occur, like diversity of flows and such. And the problems you listed look like to me that, so to say, inappropriate engineering causes these problems. Like, for example, if somebody uses pre-auth, then engineer for pre-auth and so on. If somebody uses some time-based scheduling, engineer for it. So that's my feedback. Thank you.
Jinu?
Thank you. Thank you, Jinjie, for the presentation. I have a similar opinion with Janos. I think the anomaly defined here is not anomaly. It's just a normal behavior of the switched node. A switching node can have the multiplexing of different flows, diverse flows. So there is always queue can be built up. So these things can be considered as normal behavior. And another thing is that if you define some packets are anomalous or behavior is bad, is that the fault of those flows? I don't think so. It should not be degraded or squeezed into. And if you squeeze it into another time slot, what about the packets already placed in that time slot? So I think overall, this approach has some problem. Thank you.
Thank you, Jinu. David?
I wonder about the generality of this. During the presentation, I saw a number of references to time slots that seem to imply that some of the techniques here are restricted to the periodic mechanisms.
Thank you all for the comments. Gigi, thank you for bringing this work. It's good to have new participants, so really appreciate it. Janu, just a comment back to you is maybe we should make sure to call out these different types of really normal traffic types in the example that we have in the taxonomy to make sure that they're not forgotten about. Okay, with that, Carlos.
Okay, thanks. This is Carlos Bernardos on behalf of my co-authors, and I'm going to present the draft PCA-based control plane framework for multi-domain deterministic networking. So probably you may remember that we have I have been presenting the multi-domain topic in DETNET in several meetings, originally from the wireless aspect or from the raw perspective. That was originally in draft Bernardo's raw multi-domain that then become draft Bernardo's DETNET raw multi-domain. And in that draft, we also include DETNET generic aspects, going from or departing from the wireless specific ones to more DETNET generic ones, as requested by the working group. These are basically, well, we identify also some scenarios motivating this, requiring that in the multi-domain. I will not go into that today. And this draft also proposed some particular specific solution. The goal was not to actually discuss the solution, but try to identify the need for a potential control plane-based solution for multi-domain. And after that, the feedback that I received was that the working group was potentially interested in working on a PCE-based solution. And together with my co-authors, we basically wrote this draft. So the goals and ambition for this current document is to starting or building on the DETNET controller plane framework document, focus on the multi-domain specific challenges. And we try to propose a functional framework on how to solve that or how to start working on that aspect of multi-domain. And we do that by first trying to define what constitutes a domain in DETNET in the context of DETNET path computation. And that's a very important aspect that's also discussed on the mailing list. Then we try to describe high-level PCA-based architectures to tackle the multi-domain aspect, and then identify key considerations for establishing DETNET flows across these multiple domains. So the first part, as I mentioned, is trying to define the scope of what is a DETNET domain. And there are different potential definitions that we can consider. Here I list three, there may be more, but these are three that we consider potentially common definitions of what a DETNET domain is. The first one is to consider administrative domain. So basically the set of network elements, nodes that are under control of the same administrative entity or network operator. That's one potential way of defining what a DETNET domain may be. Another one is focusing on the PCE control part, basically defining a DETNET domain as a set of nodes controlled by a single PCE instance. And you can notice that, for example, there may be very large administrative domains that may be split into multiple PCE control domains. So in that sense, PCE control domain is different from an administrative domain. And another definition that was also explained or not explained, discussed in meetings and mailing lists was the technological domain. So we can define a domain by the consistent use of a specific data plane technology. So we may have wireless domains, wired domains, or even we could consider even queuing policies or mechanisms to define different types of domain. For the sake of this document, we are basically going into the PCE definition or PCE-based definition. So we define that DETNET domain as a set of network nodes that are subject to a single consistent set of DETNET control plane and management policies. And looking into that from a PCE point of view, that will imply that there is a single PCE instance that has a complete or a coordinated set of redundant PCEs, but from that point of view, a single PCE instance that has the complete topological visibility within the domain. That PCE instance will be the responsible for computing the path and managing all the allocation of resources within the domain, so with the set of nodes that compose the domain. And that also implies that there is a trust relationship between the PC instance and the nodes that are controlled within that domain. So that's the definition that we are considering for now in this document, and that we believe is kind of the consensus from the discussion that has taken place into the mailing list. With that, we go into the architectural kind of work to see how we can tackle the multi-domain aspects in DETNET. This is a simple diagram trying to be used for the further or the work that, or the stuff I'm going to explain later. We have 3 domains here. Domain 1 that happens to be wired for the sake of this example. Domain 2 in the middle, wireless, and domain 3 wired. So basically we have a wireless domain connecting 2 wired domains. Each of the domains has a PCE controlling that. And as we will see, it may be that there is another PCE, like a parent PCE in a hierarchical topology that is in communication with the domains or the PCEs of each of the specific domains. And you can see here different routers and also different end nodes, the source and destination for the sake of this simple example. With that, the problem statement is that in any multi-domain environment, no single PCE will have a complete end-to-end visibility for the full network topology, and we consider at this point 2 potential approaches. One is the hierarchical PCE approach, in which we have, in addition to this, domain-specific PCEs that will become the child PCEs that have the full visibility of the own domain topology. We have a parent PCE that has a partial assertive view of each of the child domains. That's one approach. Another approach would be the peer-to-peer, the kind of a stitching approach in which there is no parent PCE per se, there is no hierarchy, parent-child hierarchy, and the path computation will have to be done sequentially from one domain to the adjacent domain until the end. Then some considerations on multi-domain flow, how to guarantee flows in multi-domain. So the end-to-end path computation is a concatenation at the end of the day of intra-domain path segments. The total latency, all the budgets for the latency and other QoS metrics are cumulative and has to be considered by the control plane. The control plane will have to allocate those budget, end-to-end budget among the different participant domains. And of course, depending on whether we follow the hierarchical approach, there will be the parent PCE computing that, or if we have followed the stitching approach, it would be that one domain or one PCE computes something and then pass that to the next one and the next one until the end. In terms of resource management, some considerations, of course, the resource may need to be reserved in each domain, and if some of these reservations fail, then the multi-domain end-to-end reservation will fail. The control plane may also need to advertise the different inter-domain resource parameters in order to compute the end-to-end multi-domain. And then there may be also end-system awareness considerations that are important for the future solution, whether the end systems are DETNET aware or not. This is generic considerations to be considered if we go into a specific solution work. And with that, I go to the kind of conclusions. The first question to the working group, necessary to be answered today here, I mean, is that whether you consider this is a first good attempt in trying to do what we understood the working group was asking us to do, like taking the PCE-based approach for multi-domain. And if that's the case, or in parallel to that, if there is interest in pursuing this type of work in the working group, and if that's the case, maybe in the future, call for adoption of this document. And of course,
I would actually like to ask and formally poll the second question, not the first, because I suspect that there is interest in multi-domain based on the previous discussions. And I don't want to focus just on the specific solution because I think that's a little more contentious. So if there's not support for multi-domain, then why talk about the specific solution? I'm doing the queue right now. No, I'm sorry. I'm doing the poll right now, but he was middle of talking, so I was going to let him finish talking when I say so.
Well, I'm basically done. So the question was, that's the main question to ask whether there is interest or not. This document, there is no solution per se yet. It's more like a framework considerations to be considered in further evolution of the document. So
right, you did say PCE versus domain controller. So I think you are narrowing
Yeah,
the
yeah,
scope.
well,
If you had just said
yes.
domain controller, then it would really be open.
Yeah.
So-
It's, of course, considering a PCB-based framework,
Right.
but yes.
So this, just to be clear, the poll is really supposed to be completely independent of solution.
Okay, fair enough.
Sorry, so the question really relates to how important is that to get any type of DETNET deployment first, right? So multi-domain is always more complex. If there are already, things we can do to get single domain DETNET deployments, then obviously I would love to, explore those first. But if you're saying even our first use case of deploying it needs to be multi-domain, then that would make, the priority of this obviously raised much higher. Right? So that's why without these type of answers, I can't really answer the question, because the question could be implied, sometime down the road, yeah, obviously, right? I would love to get to that point, but is it important now for deciding, if we have limited resources to work on, whether we should adopt that stuff now? So.
Okay, it's a fair question. My opinion, which is of course limited the scope of what I do in my case from the academia, we have been working on projects with industry on multi-domain. So we have multi-domain scenarios and we have been doing that in the past. So we have industrial partners requesting the need for multi-domain. Well, and we have running code on multi-domain aspects in a factory environment, for example. So there is deployment of this in a research kind of context, and there is the need from those industrial partners requesting for that as they participated in the project.
So there was, the poll showed that there was some interest in it. Again, not huge numbers. And thankfully, because you were at the mic, we had 0 objections to doing the work. But we'll take it as one objection, but we need to move on because we're tight on time. Okay. I think it is a topic we would like to hear more about. Notice we were not polling for adoptions. We're not quite there, but we had good number of people who were interested in your work. So please continue.
Hi, my name is Balázs Varga, and I would like to give a status about the DETNET data plane when we are using SRv6 technology. Just some history. So there were 2 drafts regarding SRv6 data plane. The first one was a DETNET workgroup specific draft, and its scope was to leverage the existing IPv6 encapsulation and how to use a DETNET specific seed. And optionally, you can also use the traffic engineering mechanisms provided by SRv6. This draft was just slightly updated. There were some fine tunings and some editorial updates. There was another draft which was describing the DETNET specific seed. So what does it mean? And how to extend the SRv6 network programming, the new segment routing, endpoint, and transit behaviors. Here there was an individual draft provided by our group, and there was also a Spring-related document which was triggered some years ago by the service protection functionality of DETNET. And they called it redundancy protection. Here the scope is just to define the new segment routing, endpoint behaviors, and transit behaviors. Recently, the authors of the 2 drafts were sit together, and just concluded to merge these drafts and update the Spring document accordingly. And that was able to allow that the merged draft is fully in line with the DETNET architecture. The previous draft had some limitation on that regarding the network scenarios, regarding the usability. And now with that update, it is also covering a wider range of use cases and protection topologies. So what was the major change in that document? There were seeds defined for replication elimination, and there were related segment routing policies defined. After the merge, the change was that the redundancy specific action was moved practically to the segment routing policy, to the redundancy policy. So you will need only a single seed in order to cope with protection, and this is called the redundancy seed. What algorithms you are using during that protection, this is out of scope. Of course, in case of DETNET, we intend to use the pair of specific algorithms. And the redundancy policy will contain all the configuration information. So what the service protection action does, like replication, like elimination, how these actions are executed, and what you should do on the packets which are belonging to the flow which are using this protection service. And that made fully in line with the DETNET architecture. And also, as an illustration, we have added the appendix to that document, which is showing in a complex network scenario how it is working end-to-end. What are the major building blocks of the SRv6 usage? So first of all, there is a specific DETNET specific seed format. This is called, according to the latest terminology, the redundancy seed, which can contain the sequence number information that is used by the pre-auth instances. We are placing in the argument field of the seed both the flow ID and the sequence number information. And there was a new segment routing endpoint behavior defined, and there are 4 segment routing policy head-end behaviors defined for layer 2, layer 3 encapsulated information, and they reduced versions. This slide is showing the illustration that we have added to the draft. It is showing a quite complex scenario where 4 pre-auth actions are used, 2 replication, 2 elimination. And there is a mix of SRv6 capable and non-SRv6 capable nodes in this environment. The appendix describes in detail the pre-auth actions, how you are doing the encapsulation, how you are modifying the header information fields. And there are parts, for example, the blue part, this is something where you are not using traffic engineering capabilities of SRv6 at all. In the upper part where we have the green arrow, this is a part where some traffic steering capabilities can be very useful. And of course, here any links can be replaced by a SRv6 domain in order to make even more complex network scenarios. So where we are, so currently we have updated the 2 drafts dealing with the SRv6 DETNET data plane. We are seeking for further feedbacks. Is there any need for further clarification? I think that is a question to the group, to both group, the DETNET and the Spring group. There are also discussion in the Spring working group. So we are also collecting the feedback from those guys. Thank you very much. Any questions, comments?
I don't think there's anyone in the queue. I don't see anyone in the queue, so thank you. At the last meeting, we talked about needing to coordinate with the Spring folks. I think that's still the case. I know it's early in the week and they are meeting later. It's tomorrow?
Yeah, it will be tomorrow.
Yeah, so tomorrow. So if you're interested in the topic, definitely show up there. And we will need to coordinate. This is a heads up for AD that we definitely have to coordinate this work so we don't get out of sync with each other. Nothing exciting, just standard thing that happens at the IETF. So with that, Thank you all.
Thank you.
Very much for participating in I think, a successful session here. And while it's still early in the week, we've done some good work, so feel satisfied about that. I think we're going to be moving rapidly to adoption of a number of documents. We do need to sort out exactly how we're going to get there, but we do want to keep the process moving. So thank you all. And Janos?
Thank you all. That's what I wanted to say. Thank you.
And we'll see you physically or virtually at IETF 125.
Regarding the draft, because you do the poll and the the flow aggregation across multi-domain farm, and the poll is like people spotted and no objection, but you said it's less than 1/3, and based on the colors, the next one is multi-domain farm. So is that like in the scope, or is it going for in the scope of the group, in the working scope of the group, and to go with the multi-domain and how to proceed? Yeah.
So I mean, we're